Welcome to this Fireside chat. We have Chema Del Barco, Director of Quality Engineering at Hopin today with us, and we will talk about a very interesting topic, which is how to adapt the testing, development process in your team to make sure you're much more effective and you can deliver new features much faster to your customers. Just a quick intro for those of you who are new to our events. Adeva is a remote network of tech professionals. Our vision is to really work without boundaries. So these events are kind of connected to the same vision where everyone's able to learn from tech leaders like Hopin, regardless of the location you're in or how it works, basically. Before we start, just one note, so you can leave questions in the Q&A section. We will circle back to all of those at the end and try to answer as many as possible. Okay, so without further ado, Chema, welcome.
Thanks for having me.
It's a real pleasure, especially the topic and knowing how passionate you are about it. To start off, maybe we can do a quick introduction, tell us a bit about yourself and also what made you explore this topic.
Sure. So, I'm Chema Del Barco. I'm the Director of Quality Engineering at Hopin. I've been working in testing for like 12, 13 years now. I've been going around quite a bit around Europe, especially. I've been working in startups, been working in corporations, in banks, a little bit of everything. I love testing. I'm a telecom engineer, but I love testing. So it's always been very, very challenging for me to try to break things. And all of these like varied opportunities I've had, like working in different markets and different areas, there's been a lot of trial and error trying to make sure that that quality and testing adapts to the way that or the needs that the company has, the needs that the customer have. No? So it's been kind of like a natural evolution of the processes. No? But I think that most importantly has been related to breaking misconceptions around how to build quality. For example, there is this misconception that in order to deliver changes at speed, you need to sacrifice quality or you need to sacrifice scope. That these things cannot go together. And this might have been true for like old-fashioned like methodologies, but with modern tooling and with modern methodologies and modern software development, modern libraries, it is much easier to actually be able to put all of these things together. There are many companies that actually have the need to deliver very, very fast because maybe they want to disrupt the market, like Hopin wants. Maybe they want to get a piece of the cake. Maybe they need to take an opportunity, right? But at the same time, these companies cannot afford to have bugs and have bad quality because that can very quickly turn their customers away to the competitors, right? And most importantly, because having bugs in your system means that your customers are mostly talking about bugs to you, and they're not talking about how the products you're building are actually satisfying their needs. So you are missing an opportunity. There's a lot of noise in there, right? So the better the quality, the more your customers are going to focusing in providing you with feedback about whether you're satisfying their needs or not, and then you can react very fast. No? So these companies, I mean, they had to challenge themselves, no? And they invested a lot of money in creating tooling and ways of automating things and changing their processes. And these companies, this is the reason why things like agile methodology was created. No? And it's all about limiting the scope to very small deployments with high quality and speed. No? And then by releasing very, very fast, even if it's a small scope, you can actually get a really big scope very, very fast as well. No? So there is this misconception, and many companies still don't know that you can actually reconcile all of these things. But then you can say, well, I don't work in this kind of companies. I work in a bank. It's a very big corp, regulatory environment. And there is this misconception that stability means rigidness. It means being slow. It means having lots of regulations and rules, and the don't move, because if you move, you have risks of changing things. No, I have worked also in these kind of companies, and you see them eventually halting to a full stop, because the amount of rules and the amount of processes that they have, they just don't let them move anymore. It's too big, right? And the changes are so many that it's really, really hard to be able to build real good quality. So some of these companies try to go to agile, and many fail very, very badly. They start doing this kind of like 2-week waterfalls, and that they call agile. But some of them actually realize that you can separate delivering changes to production to rolling out changes to customers. You can actually increase the pace at which you are deploying things to production without showing any of that to customers. So you have customers, I don't know, in a bank, for example, and the customers don't want to see changes in the platform all the time. I don't like to see changes in the platform all the time, because it's my money in there, right? So I'm a tester, so I know that changes mean that something can go wrong, and customer is the same, right? So, however, you can still deliver these very, very small scope changes very fast with a lot of quality, changing your processes internally, and then decide, okay, I have a good amount of, let's say monthly, I have a good amount of features. Now I'm going to roll them out. And you can give the capability to product and business organizations to decide how they're going to do that rollout. So in fact, if you think about it, fintechs are, to me, they're the companies the banks that have discovered this. And they are disrupting the market, right? Like, because they are so much faster, so much more flexible than a traditional bank, to the point that traditional banks really needed to start adopting these processes in order to become competitive, right? So that's where fintech strength is, in being able to be very, 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 very specific, like a surgeon. So then there's another one of my favorite misconceptions, which is something I've been working all my career, is this thing that developers cannot test or should not test what they build. I wholeheartedly disagree with this. And the reason is because, to me, an engineer, a software engineer, needs to take ownership and needs to be accountable for what they build. Otherwise, they're just coding. They're just coders, right? So you're an engineer. You provide solutions. You don't provide just pieces of software. You provide a solution that works, right? This is why companies that have traditionally invested a lot and being able to become really, really fast at delivering software with quality, like Google or Facebook, maybe they are not as good as they were in the past, but these companies have tens of thousands of developers, and they almost have no testers. And the reason is because they learned that they actually understood that if you add a testing phase or a stage, or even just an extra person that is looking into things, you are making your delivery processes ineffective, and you're making them very slow. Why wouldn't a person being able to, someone that actually builds everything, obviously it needs to be supported, it needs to have the right understanding, right? But if these persons get this right understanding, and that's why Facebook and Google, they only hire for this kind of developers, the ones that can prove that they can take responsibility end to end, that they can test at all levels. There's plenty of videos in YouTube about GTAC, for example, Google Test Automation Conference. You can see a lot of material in there where they explain how they test for Facebook as well. So you put all of these things together, you try many things, you fail many times, you succeed some of them, you get the ideas in common, the things that worked, you put all of that in common, and you come up with a way that it's working very efficiently and usually very fast.
So we had not having to sacrifice quality over speed, then separating deployments from features customers see, and at the end, developers not being able to test for being able to test. And this last one especially is an interesting point because, I mean, most of the developers I know, they hate testing. And I guess the reason is that they're able to rely on someone else to do it, considering the traditional environment and all of that. And I was wondering how difficult is it to hire for a person who, you know, is in this mindset to develop everything and test everything and just deliver the full solution. And then on the other hand, you have engineers on your team already, how hard it is to, you know, go from the current mindset to this new one.
Yeah. So on the hiring side, we put a lot of effort during the hiring process to make sure that the people that we get from both from testing, because obviously we do have testers. I will explain later, but especially on the development side, they have the right mindset. Mindset is really hard to change. Some people would say that either you have it or you don't. And the only way that I have been able to effectively change mindset is through engagement, you know, like making people part of the problem. We also have a career framework in which we define the different levels of seniority, etc. At Hopin for developers, for testers, for all the roles. And we put a lot of stress on making sure that people understands that in order to grow in your career as a software engineer, software tester, you need to make sure that you take ownership of what you build. And we specify what it means, no? Like you collaborate with people from the test team, from my team, and especially you ensure that what you are building, that it goes to production. When it goes to production, that is working properly, etc. No? And so it is not easy. It makes things slower because, as you say, there's a lot of developers. To me, they're not developers. Again, they're coders. You know, my 11-year-old nephew is a coder as well. So to me, finding these people is harder. It takes longer, but it pays off because obviously there's a much less effort to do if you don't have to convince people that this is the right way to do it. On how to change mindset. So when I joined that Hopin, so Hopin obviously is one of these first type of companies that I said before, no, like the one that needs to disrupt the market. It needs to be super flexible. It needs to be super fast. But at the same time, Hopin is growing incredibly. It's one of the fastest growing companies in the world. When I joined, there were 40 engineers, and now in 8 teams, and now there's like about 200 engineers in more than 20 teams. All of them, most of them, contributing to just 2 repositories. So now you have way more work coming in than before. How do you make sure that you start changing the mindset to all of these people? The ones you hire, yeah, you can hire them for that. But what about the ones that were there? So when I joined, in fact, I was talking to people in the teams, and they didn't think that the quality was very, very bad. So they didn't have a problem, right? So testing was done manually. Releases were done manually. Everything was manual. We were still changing. We were still deploying every week with all the processes manually. It was a horrible scrum or fall, you know, like, you know, 2 days of manual testing, the 3 days of development, no? So, and then the teams didn't have the perception that things were failing in production. They thought that it was good. So I started talking to customer support, and they were like, oh, "No, there's a lot of issues." Okay, so how do we get this done? One of the things we did is add a lot of observability, like make it very evident. We started tracking everything from the release point of view. We started tracking bugs, how many fixes we had to do during regression testing, after regression testing before it was going to production. How many hot fixes after production, which teams they were coming from, who was responsible for it, how long it was taking to fix. We started creating dashboards that would make things very, very evident and start tracking evolution. When you show that to everyone, there's no escape from it. There's no escape from data. So being able to become aware of your own limitations is the first step. It does just basically, we broke them down. We broke that false sense of confidence that they had, and then everyone realized that we have a problem and we need to be much better at this, which makes things much easier, right? And then we start working on how we fix all of this, no? Which we can talk in a moment. But for me, the most important thing is what I tried explaining everyone. To me, the goal is to optimize what I like to call the product feedback loop. So what I was mentioning before, right? So how much it takes from idea, from need, into a product that can be monetized, obviously, because we're a business, so we make money out of it. No? So how much time it takes and what's the process to get there? And in order to optimize this, I mean, that's the goal of an engineering department, right? I mean, if you think about it, the goal of an engineering department is to enable that product feedback loop to be the fastest, the most reliable, and the most seamless that is possible, right? So that, let's say, you don't have to really think about how you're getting from A to B. You just do it because it's part of your process. And that's where that means that there needs to be a like engineering feedback loop inside. So the engineering feedback loop goes from design to delivery, right? And then after it's delivered, which is this separation between delivery and release and rollout, once it's delivered, then product can take the decision to how, when, and to whom is going to be rolled out, right? And that's what's giving a lot of flexibility to product to make sure that they can get as much feedback as possible. So then the goal is how you optimize your engineering feedback loop, right? So, and that's where all of these mental process of how you can actually get a lot of brainstorming and a lot of work on how we make this happen. So to change the mindset, so to change this process, I've seen many companies trying a top-down approach, meaning, it is mandated. We're going to start working like this, and you follow. These are the new rules. These are the new processes. We will teach you how to do it. And the problem is that engineers, they react really bad at that. They're really, I mean, we're really bad at following these kind of mandates, but it's perfectly normal because engineers, we are educated to understand problems and be part of the solutions. So top-down approach is never going to work, because even if you can implement it as soon as is possible, the teams are going to go back to old habits because it was working for them. They don't understand why they were needed. So we spend a lot of time in messaging, over communicating is a common thing of all the companies that are remote. And we really try to communicate as much as possible this message, the message of there is a need. And the need is we are not doing enough to enable our business to be this competitive and ambitious business that we need to be in order to be where we want. And then things start rolling. No? So the good thing of it is that you have to. So how do you do this bottom up, which is the better way, no? Like explaining this and showing the way, no? And testers usually are pretty good at this because they are usually put in this position that they are in the middle, in between product, in between development, no? And they always need to take that one step back to have this holistic view, no? And at the same time, they're pretty close to what's going on. So they're there every day. They're part of the stand-ups. They're part of the planning, etc. So these people is in a really good position to actually start making this change happen. But then there is another challenge. So it's like that. I think is very special to Hopin, which is that we move really fast, like much faster than any other company I've ever worked. And I've worked in really ambitious startups before. It's kind of like this kind of super fast train that that cannot stop. So how do you make all these changes? Because normally a bottom-up approach takes time, right? So in fact, the example of the train is pretty good, because imagine that you have this super high-speed train, and you really need to get to your destination, because otherwise something really, really bad happens. I don't know, it explodes or something like this. And so that means that, I mean, I think there's a TV show that is kind of like that. So anyway, if you know that you need to make it there and you need to make it as fast as possible, but at the same time that the train is not good enough in order to make the trip, you need to change it as it goes. So in this case, you need to make sure that your crew is going to be able to change things as it goes, right? But now, what is the better approach in here? To just have some technicians that are very, very specialized in specific parts of the train, so that if there's something happens in that specific part of the train, they will be able to go there and fix it super fast, okay, with super experts, okay? But the problem is that depending on where it fails in the train, you need different specialists. So you're going to need a lot, and you're going to need to react very fast. But the other approach is you have specialists that maybe they are not experts in one particular thing, but they know a lot about everything. Mm. And then if there is a problem, most of the times that there is a problem in the train, those people that are more generalists, they're going to be able to go and fix it. If you just add a small group of specialists, just in case, to cover for that part in which the generalists are not able to do it, then you are pretty safe. So that's exactly what we're trying to do here. We are teaching our developers to think like testers, and we're teaching our testers to think like developers, so that we all become generalists and we can all do everything, and we don't need other people to help us. So that's kind of like what our test engineers do. No? They work in the teams, but their job is not to provide feedback. Their job is to help the team, ensuring that they are self-sufficient in getting that feedback and acting on it, and in measuring the quality that they're building. So they do work with them. They are embedded in the teams, but they mentor, they pair with them. Right. They receive. I mean, we're trying, okay, because this is a transition period, but the goal is, that they don't test things. They pair with developers so that they all together test things, so that the next time they will not need it. But at the same time, we need a lot of tooling, because you can't just go and say to teams, hey, you just need to build quality. You need to enable them to build quality and to measure it, right? So that they understand whether they're doing good or not. And in order to do that, then we need to automate everything. And we need to be able to create tools that are specific to the challenges that they have in the areas they work. And this is why we have a different role that we call SDETs, which are developers in test. And these people work explicitly making sure that all the automated feedback, all the automated tests run as fast as possible, as reliably as possible, that the teams have tools related to test data, reporting, that they have all the tools they need in order to build their quality. So that's the two different roles that we have.
So they're the specialists.
Those are the specialists that, in case, test engineers kind of get, and honestly, it was the reason why we decided to make this distinction of roles, because, to be honest, one thing that we know and we see is that the more senior the test engineer is, especially working in this kind of approach, the more they work in this kind of approach, the more they become both SDETs and test engineers, which is what I like to call quality engineers. Like, they are overall people, they are full generalists, right? So right. They become experts over everything. So it's an evolution also. It's a career expectation as well. And it is also very good for testers, because they know that they don't have to switch to a different role in order to do more automation. They know that we are all going there. We know that in the vision is that all of the people in my team will be quality engineers that will be able to go to a specific team, spend some time with them, help them grow their engineering maturity, their processes, their automation, etc., hands-on, and then either leave when they have already reached that, or help with other areas like non-functional testing, which is a classic area that is always relied to the last thing. So that's where we are evolving.
Right. I'd like to come back to this about the role of test engineers and people who are already focused only on testing in the team. But let's just go back a bit. I know you already started talking a bit about the process, but I just wanted to give you the opportunity to explain how everything works and basically what was the reason you started implementing or switching from a more traditional manual process. You also touched a bit on that.
Yeah.
And do you already see some benefits, or what are the benefits that you envision after switching completely in this direction?
Yeah. So as I mentioned, we did this out of a need. It was getting to a point soon when I joined. It was getting to a point in which there were more and more issues in production. Our platform was becoming more and more visible. It was reaching more and more people. And we couldn't afford these small things that happen in production that maybe they're very, very, stupid, I would say, like the classic miss that you have that you can fix very quickly, but when you can reach a lot of more people and you are in a moment in which you really want to show off, you can't afford these kind of like very small issues, not even the small ones. So we needed to change the way that we were releasing software. For starters, back then, anyone could actually do a hotfix in production, anyone. And they didn't need anything in particular. They could just go to production, and so they wouldn't go to production and fix, but there was a way for them to actually release a hotfix in production without much issues.
Right.
But hotfixes were causing lots of issues as well. So one of the first things we did was to create what we called the release control tower. It's kind of like a control tower in an airport. That basically there would need to be some approvals, and they would need to check everyone before going to production. They would need to check with the control tower whether it was okay or not. And we took that chance to ask some questions, basically just to make sure that people was doing the minimum due diligence, right? So testing, how this was tested, pass the automated test. By the way, we have a really good unit testing coverage in our platform since the very beginning, like more than 85%. It's really high. So, and then I was getting questions sometimes from developers, from testers, like, why do we? So we have 85% unit testing coverage. Why do we need to be so picky about whether we can go to production or not? And the answer is because every regression test that we do every week finds bugs, every single time. Every time that we release changes, we need to hotfix. So yes, we have 85% coverage of unit testing. That's great. But unit testing, the scope of unit testing is not to tell us whether the platform as a whole works, is to tell us whether the logic is sound or not. So if we don't have anything else, which we didn't back then, we don't have enough information. You get a false feeling of trust and confidence if you think that just because you have 85% unit testing coverage, you can go out, right? So that was another misconception that we have to fix internally at Hopin. So we started putting this process. Immediately after that, we already saw a decrease, dramatic, in especially the biggest incidents, the biggest impact incidents, dramatic. It was definitely the right way to do it. It was obviously very, let's say, challenging, because suddenly developers couldn't do, we were taking one of their freedoms, right? So we were starting to ask questions about things and they couldn't just go. So it was challenging, but they realized very, very soon when we started creating all these dashboards that it was worth it. Another of the issues that we had to fix is obviously a product feedback loop. It doesn't work unless you have a way to capture feedback and make it back to engineering departments. And our bug management, your incident management process was not working very well. The engineers were not, they didn't get that visibility of the issues that customers are reporting. And we were having lots of issues. This level of noise that I was talking about before, because many times the first time that we knew about a bug was because a customer was reporting it. Fortunately, this is almost like a thing of the past already, because since we started working on all these process improvements and release improvements, etc., we have dramatically decreased, and it's a very lowering trend of the biggest impact incidents that we have in production. So we went from more than 10, 15 incidents per week to an average of 3, 4, which is much better.
Yes.
Obviously, so yeah, sorry.
And it's only a few months, right?
Yeah, so just in a few months. So we are still not there. We still have a lot of parts that are manual, but we're putting a lot of work together and many different parallel initiatives that are different pieces of the puzzle that we're going to connect all together, and is going to bring us to a different level. So 3, 4 is much better than we were before, but that's what we could do only with, let's say, the mitigation. But in reality, the real work is being done behind, in changing architecture, in changing our cloud infrastructure, in changing, in separating better our definition of like what is delivery and what is release. We for example, use feature flags extensively so that we can make changes in production without making them available. And we have different levels of feature flags by event, by customer, so that we have quite a lot of flexibility, and we're going to make it even better than that. But we are already getting ready to be able to deploy to production as fast as possible, instead of doing it once per week, which we still do. But having the tooling, which is almost there, is not enough, right? You really need to make sure that what you are delivering has the right level of quality, and that you are confident that eventually you can do one-click deployments. And say, okay, this feature is ready, and it has a CI pipeline, a continuous integration pipeline, and a continuous delivery pipeline. And you know for a fact that if nothing goes wrong there, it's safe to be deployed to production and to be rolled out, right? So we're still a long way from that. I mean, a long way at Hopin is 3 months. So a long way means like, so one of the things we're doing is automating everything. But most importantly, all of these manual regression tests that the testers were doing every week, these 2 days, we are automating that. And we are doing this, it's not the testers doing this, only, it's the teams. And I think that this
how much have you automated already?
So we have about 40% of everything, depending on the team, but globally we have around 40%.
Yeah, that's nice.
This is more than twice what we had a month and a half ago, and it's an outstanding effort from all the teams. Like, we are literally dedicating a percentage of the capacity of the teams, of every team, to do this, because we know that it's key for us. We need to be able to go to production much faster than what we are. Once per week is not enough. We need to be able to adapt to our customers' needs much faster than that. So we all know that, and we know that in order to enable it, we need to have a safe net, right? And we're aiming for at least 80% of the coverage. But at the same time, we made sure we did a prioritization exercise. So all our tests they have different priorities, And we started with the most important ones, then the P1s, and then the P2s, right? So that 80% is the 80% that covers all P0s, P1s, and then some P2s, which are usually more trivial things, right? We want to make sure that we get that 80% of confidence that, will tell us, obviously we'll go to 100%, but at least for starters, we want to have this 80% coverage. And then we'll start doing automatic deployments. We will probably much sooner than that start doing releases on demand, so that we don't have to stick to a weekly release cadence, that we can start releasing when we feel confident.
Still manually, right?
Say again?
Still manually for now.
The deployments are mostly automated. So we are also switching. We're switching from we're switching cloud provider from Heroku to Kubernetes and AWS, and we also are switching from GitHub to GitLab, and we are automating all the process, and that is also allowing us to create review app environments. So we can generate environments on the fly so that all the automation can run in those environments. And that is going to be super important for us, because that will switch our continuous integration approach from post-merge, which is the current one. So right now, everything is triggered after something is already merged. And we will switch it to pre-merge. Like, you don't merge unless you prove that it works. Right? So we're putting a lot of effort on this, and obviously we need to make sure that our testers are working on, and our SDETs are working on making the automation as fast as possible. So that right now it takes over an hour to run all the tests we have. The more like UI level tests, I would say. The rest take much less, obviously. And we want to obviously put that down to 5 minutes. 10 minutes, right? So that we can, because otherwise it would be unfair to ask for teams to wait for 1 hour to see whether their change is passing or not. No, so when it's 5-10 minutes is perfectly fine, because it's usually the amount of time that it takes for a code review to happen anyway. So our pull requests would do everything in parallel.
Nice. You mentioned feature flags. Are there other similar strategies you use? And also, are customers so if a customer sees the feature first, are they involved somehow in the testing afterwards, or do you get their feedback?
So that is also something that we are transitioning to. So we are currently evaluating how to do this properly, how to do this in a way that it doesn't disrupt our biggest customers, the ones that perhaps require a little bit more stability, as we were mentioning before. But at the same time, not losing flexibility. And hey, for those ones that actually are fine to try out things, which we know, we engage with them. We release things in beta, right? And then we just enable the flags with them, and they know that they're getting something that is perhaps buggy or not fully finished, or there's missing some features. And they provide lots of feedback. So usually our collaboration with our customers, the organizers, is really, really good. But it is, so we're discussing whether to do something like GitLab does, for example, that it's like they have a monthly cadence for their enterprise users, and for their free users, they release as they go, basically. So that from the free users they get lots of feedback, but only when we are 100% sure. Again, it's not about bugs. It's about making sure that
feedback. Sorry.
Oh, is okay?
No, yes, I was just saying user feedback, like how they experience.
User feedback is the actual user the product feedback, the one that we want to get, right? It's not about the bugs, no? So we will always aim to release the biggest quality possible, even especially, I would say, when we do it faster, right? So it's about making sure that the products we build are satisfying the needs.
Great. Let's see, I had a few more questions. Oh, I wanted to circle back to the test engineers. So
Yeah.
I know now they're working alongside developers, they're pair testing, writing tests and everything. So what's the long-term vision for the test engineers on their team? What will their role be after developers become self-sufficient and able to do all the work themselves?
So, I mean, there's so much work. So right now we're mostly focusing on functional testing. We do have some teams that are working on non-functional testing, but it's something that is ramping up as well. So the non-functional testing part, security, performance, accessibility, it's kind of like already looming in there. It's coming. And it's something that definitely we need to support. And it's something that we really want to help teams to make part of their CI/CD pipelines as well, right? We want non-functional testing to be done in the same way that functional is equally important. We have more and more customers. We have SLAs that we need to meet, also from performance, timeouts, etc. So we need to make sure that we cater for that. But so the quality engineering team at Hopin is never going to grow proportionally to the development team. Our vision is to reach our critical mass of engineers that are going to be able to help multiple teams and different, right? So basically go to one, it's kind of like a SWOT approach, right? To go to one team, help as long as needed, but then disengage and ensure that the team is self-sufficient. So the way that this is evolving, as I mentioned before, is kind of like all of the roles are merging into more of a quality engineer, someone that's going to be able to support teams in many different things, not just testing, not just related to testing, is related to quality in general, to criticize the product, making sure that we have the right approach to design, to test, that we have testability in mind in our architecture decisions. So they're going to be pretty much everywhere. And at the same time, they're going to be able to give feedback when it is a little bit trickier. Like testers are really good at exploratory testing. They're really good at thinking, what if, no? And they're really good at this thing. So they're always going to be supporting that side of the teams as well, because we want to make sure that our products, that we are the first ones, not the customers, but we are the first ones that ask the question, is this satisfying the need of the customer? No? So once we have those feedback loops fully in place, there's going to be a lot of data, a lot of information coming, and there's going to be also a lot of work in that area. So that's a different level of quality. Obviously, we're going to allow everyone to specialize. In the times I've done this in other companies, many testers become developers.
Oh, interesting.
Yes, because so it's, and that's which is another misconception, right? Like that I will always remember when if you ask testers why they became testers, and there will be always someone that will tell you, because I was not a good enough developer, which is not okay. Okay, so it's all the contrary. So the testers are now getting much closer to what is being developed. They're having this conversation with developers about how to unit test this, and what it means to unit test this. They're getting closer to the code. They're learning. They're part of the code reviews. They actually can find bugs in the code, which is great, right? So when they start doing this, many testers just feel like, okay, so what's the difference between actually doing this and building the code myself? And they start sometimes taking some tasks. Hey, can I perhaps try this? And they like it, and they switch to developer. That's perfectly fine. Some others like the product side of it, the design of it, and some will move to product for sure, right? And some will specialize in other areas of testing that we have not even thought about, like AI, how to make test automation even more efficient, how to make sure we have the right infrastructure for automation, how to make 10 minutes test run a 3-minute test run, this kind of challenges.
So it's like with full stack engineers, people are generalists. They do work on both backend, frontend, everywhere where needed, but everyone has their special side and they specialize into something more unique.
Of course, they will always have like a one thing that they like more. But I believe that a tester can be a great developer and a great product manager because they understand parts that traditionally are not what like developers' responsibility,
Right.
and that gives them that extra edge. So
the analytical mind.
If you're a tester and you become a developer and you don't do proper unit testing and you don't do, it's very weird. It's very rare to find a developer that was a tester that is not doing amazing test coverage because they know
Right.
the value, right?
Yeah, they know what to focus on.
Yeah.
We have quite a few audience questions. I suggest
Sure.
we start with them. There is one around manual QA. So manual QA usually catches something really important for companies, customer experience. How companies that adopt this process understand how customers interact with their products. So
Yeah.
the exploratory testing maybe that you mentioned.
So I think that it's a very good question. It wouldn't be possible to do that unless development teams have end-to-end responsibility over what they build. They need to be connected to how they are impacting customers. They need to be connected to the feedback that those customers give. And that is exactly what I was mentioning about this product feedback loop. That is closing the loop. The incident management, it's also extended to, let's say, product feedback management, and how feedback coming from customers is transformed into changes that need to be reapplied. So it's very important that the teams keep the holistic view of the platform that they're working on, that they don't get siloed into just a particular service or a particular part of the application they build, that they always take part of the responsibility over the full platform, right? Because after all, that's what the customers experience, the full platform. So we are building now these interfaces. What are the boundaries between within the responsibilities of the teams? Like who owns what and who owns the full process? And so we're making sure that there is always an overlap, so that it's not me finish here and me finish here, and then no one actually does the full thing, right? Like this team needs to make sure that their area of impact is also working properly, and so is the other, even if it includes parts that traditionally wouldn't be they're owned by them. About the customer experience, our customer support is collaborating closer and closer with engineering, and this naturally, when you are a small company, you have customer support and you have engineering, right? But when you grow, and especially when you want to give more responsibility, when those two teams start collaborating more, it surfaces the need of kind of something in between, kind of like a technical customer support, no? Like a team that actually already understands what is the implementation of the features, so that they are able to help customers much better. We are also creating a knowledge base of all the kind of like workarounds and issues that we have, and how you can solve it, whether this already has been reported, so that our customers would be able to go first and check, hey, has someone already seen this? Is there a way to go around this? Because there's an infinite amount of ways that a user can use something outside of what you thought that they were going to do. Infinite, you wouldn't believe it.
Yeah. So basically, instead of having the manual QA get in the role of the user, you ask the actual users and then connect the feedback to the developers so that everyone is aware of what happens.
Yeah. So the QA is always going to, so they are experts on that, no? But it's very important for us that it's not just the QA that is capable of taking that step back. That is the whole team, and also that also includes product managers, and everyone should be able to have a full understanding of what are the specific applications they're building in the team, and being able to react to any customer question. In fact, they do. I mean, the teams are the second level directly. So the second level customer support are teams. We have a lot.
No, go ahead.
I was going to say, we have the concept, which is something quite new for me. We have a concept of what is called a time-sensitive issue. A time-sensitive issue is a specific bug or something that the customer cannot do, and it needs to be resolved within a certain amount of time, for example, before the event starts. And that gives us, is not like a super product incident, because, like a production incident, no? Like, it's not something that needs to be fixed immediately, but that gives us that connectivity between the customer and the engineering team that is so important, because then we can ask questions, and we can, the customers are also really reactive on this and very proactive, so they really try to help as much as possible, because obviously it's in their own interest to fix the issues. So it's a back and forth, but still very constructive. It's
like what happened when we were preparing for today's event.
Exactly. So we had some issues with the event, and I was trying to go through testers and customer support and everything, trying to get it fixed, and well, here we are.
Made it. Perfect. And I wanted to add on this. I read once about Zapier's approach about all of this process. They actually have engineers work as customer support once in a while as well. So whenever they hire someone, their role is, again, a generalist, someone who can put different hats and understand customers and then deliver value to them. So I think it's on the same point that you're making.
We also are going to make that explicit program. So we want we already run a trial of engineers attending calls, customer support calls, so that they see. I mean, I told you today, right? Like, by actually going with you through the issues that we had, I learned a lot of things that, unless you actually go and see these things and see how users are impacted by these things, it's really hard to be able to get, because you are biased, right? You know already how the application works. Yep. So your expectations are different. So that gives a lot of information. It's really valuable for us.
That's great. I'm looking forward to see how that works out with the customer support and all of that. Another question, which companies or teams would benefit the most from this approach, and which would benefit the least? Or when does it not make sense to go through all of this?
So I think that especially teams that need to be able to change very fast, and they cannot take the risk of having bad quality. I was mentioning Facebook and Google before, right? So I mean, these companies at the beginning, these were the companies, some of the companies that were the first doing this kind of approach, and Microsoft, etc. Right? So, but Facebook is a different company now. In fact, Facebook does a lot of testing in production. The users are their testers. So I know for a fact, because we have several people coming from Facebook that at Hopin, that they are hiring testers again, because they went back to old habits. And in fact, what happened is that they got too confident, and the quality was starting to be a little bit too much, and customers. But I mean, Facebook is an application that is not paid per se, right? So when you are delivering something that is paid, a paid service or a paid application, it is very important to be able to still be able to react fast, but with very high quality. So those are the companies that are going to benefit the most. However, that being said, even companies that are much more rigid, they always benefit from this as well. When they realize, I mean, if they try and can implement this properly, I've always seen huge improvements on the side of, at least, I can say, at least on the mental health of engineers. because engineers always want to be able to release fast. So the ones that benefit the least, well, maybe high regulatory. Okay, so you're going to be able to do this on applications that really can't change fast. I don't know, navigation systems. You want to make sure that everything is very checked. In regulated environments, there are regulated environments that really need to go through extensive validations specific to the regulations, right? So it's very, very slow anyway. So if you are not going to get any benefit by being able to go very fast and have very small increments, if you don't get any benefit out of it, I would try to adapt the process so that it's a little bit more relaxed, because I can tell you, it is intense. To do this is very intense, especially to do these changes as fast as we are doing it. I would try to maybe do like a typical bi-weekly release, like this kind of thing, like a 2-week sprint and release after every sprint, this kind of thing. Mobile applications, they usually don't change that fast, because they can do this difference between delivery and deployment, but and rollout. But in fact, they don't. You can't just. I get really annoyed when I have 33 applications and I need to update. And then 3 days later I have to update again.
That was an excellent example. Can you we have 3 more minutes. Maybe we can go with this question to close up. Can you quantify how much faster you are delivering now compared to previously? I'm not sure if it's too early to say this.
So I can tell you, we do regression testing in half the time now, because of we already backed up by automation, which is like we have like about 40% coverage, right? Mm-hmm. But so we release in the same cadence, because our way of transitioning from where we were, which was continuous build, basically. We were just like, the only thing we were doing continuously was to build the application, and that's it. We were not doing testing, continuous testing. But now we're transitioning to full CI/CD, right? So that's the complete opposite, like to deploy automatically anything that is ready to be merged. So we still release weekly, but by usually the end of the summer, we want to be able to do already full CI/CD. So we should be able to at least to have the capability to deploy any change that is any feature, let's say at feature level, any feature that is considered done by the team, to be able to deploy it just with one click with all the validations and everything in between. The best thing about Hopin is that, we have a lot of people working in there that has also been like a little bit like me, like working in many different companies, trying many different things. So when you get together all these kind of people that has already seen what works and what doesn't, you can actually skip steps. And that's how we are doing it so fast, right? Because we already know that what are the different steps that we traditionally would go through. That means that we have a specific steps, like, okay, what needs to happen in order to go to this next stage? Okay, so why not just working on the next one directly, right? And we do that with all the initiatives that we have. And this is an approach that usually for any other company I've worked, it takes even years to do that transition. And at Hopin, we're gonna do it in 6 months.
Everything is so much faster with you.
Intense.
Intense. Great. Do you have any final thoughts you want to share to close up the event?
So I just want to tell the audience, I know that when you work in testing, all of these things that we have discussed today, they are the very classic problems, right? What I want to encourage people to challenge the status quo. It's very, very important that we convince people to, to be able to try things. Trying things is really important. I wouldn't be able to do these things unless I was given the chance to try before. Sometimes I failed, but then we tried again and until it succeeded, right? So make sure that you challenge the status quo. Make sure that you challenge all these misconceptions that we have, and learn about how other companies are doing it. And most importantly, your best help, your best friend is awareness, is visualization. Make things very visible. Make the problems very visible. Make it with data so that no one can get away of it. Create dashboards that is automatically showing the quality that the teams are building, the times that the builds are failing, so that teams really see that they're doing something wrong and they work harder. Do not assume testers. There's always this disparity, like this conflict, devs versus testers, right? Many times testers assume that devs don't want to build quality. It is not true. That is another misconception. Every single developer that works at Hopin, for example, I know that they're trying their very best. I know that bugs don't happen willingly, right? We're trying the very best, and we have lots of different pressures. Bugs happen. We are human. We need to remove as much human part of the process as possible so that we can focus on being our human part should focus on what we're really, really, really good at, which is not necessarily do automated things, because machines can do that, repetitive things. Is at really putting thoughts about whether things are matching the needs of our customers or not. Are we building the right thing? Not building it in the right way can all be automated, but building the right thing is the most important thing. That's how you are really going to give impact to your companies. No, that's how you're going to become really useful to your companies, by making sure that you put the right effort in the right place. So everything else automated.
That was excellent. And there was this question that we didn't get a chance to get to, which asked, what is the part that cannot be automated and will always need a human touch? I guess you answered it very nicely right now.
Good.
Great. Well, Chema, thank you so much. I really enjoyed the conversation, and it's very, very insightful. I hope everyone also took something important out of it. This will be on our YouTube channel very soon. So if you want to rewatch something or remind yourself of some of the concepts we discussed, check it out again. And also, don't forget to check out Adeva if you're looking for a remote job, if you're looking to hire remotely, and check out Hopin even if you're not organizing an event. There is this very cool feature for finding interesting events coming up, so you will definitely find something that would be useful or interesting to you.
Katerina, I'd be happy to. I know that there are some unanswered questions. I'd be happy to, if you put them in a LinkedIn post or something. I'd be happy to write some answers.
Oh, awesome! We can do that. Perfect. Thank you, Chema, again. See you all next time.
Have a good time. Bye.
Bye bye.